Combinations and permutations. Combinatorics is the branch of mathematics studying the enumeration, combination, and permutation of sets of elements and the mathematical relations that characterize their properties. Enumeration is a method of counting all possible ways to arrange elements. Although it is the simplest method, it is often the fastest method to solve hard gmat problems and is a pivotal principle for any other combinatorial method. In fact, combination and permutation is a shortcut for enumeration. The main idea of enumeration is writing down all possible ways and then counting them. Let's consider a few examples. There are 3 marbles, one blue, one grey and one green. In how many ways is it possible to arrange marbles in a row? If we write out all possible ways, the answer is 6. In general, the number of ways to arrange n different objects in a row. Example 2. There are 3 marbles, one blue, one grey and one green. In how many ways is it possible to arrange marbles in a row if blue and green marbles have to be next to each other? Let's write out all possible ways to arrange the marbles in a row, and then as we can see, we can find only the arrangements that satisfy the question's condition. So the answer here is 4. Example 3. There are 3 marbles, one blue, one grey and one green. Then how many ways is it possible to arrange marbles in a row if grey marble has to be left to blue marble? Let's write out all possible ways to arrange marbles in a row and then find only arrangements that satisfy the question's condition. The answer is 3 arrangements. Arrangements of n different objects. Enumeration is a great way to count a small number of arrangements, but when the total number of arrangements is large, enumeration can't be very useful, especially taking into account gmat time restriction. Fortunately, there are some methods that can speed up counting of all arrangements. The number of arrangements of n different objects in a row is a typical problem that can be solved this way. How many objects we can put at first place? N. How many objects can we put at second place? N minus 1. We can't put the object that already is placed at first place. And so on till n. How many objects we can put at nth place is 1. Only one object remains. Therefore, the total number of arrangements of n different objects in a row is n is equal to n into n minus 1 into n minus 2 so on into 2 into 1 is equal to n factorial. A combination is an unordered collection of k objects taken from a set of n distinct objects. The number of ways we can choose k objects out of n distinct objects is denoted by nck. Knowing how to find the number of arrangements of n distinct objects, we can easily find the formula for combination. The total number of arrangements of n distinct objects is n factorial. Now we have to exclude all arrangements of k objects, k factorial, and remaining n minus k objects, n minus k factorial, as the order of chosen k objects and remain n minus k objects does not matter. So nck is equal to n factorial by k factorial into n minus k factorial. Permutation. A permutation is an ordered collection of k objects taken from a set of n distinct objects. The number of ways how we can choose k objects out of n distinct objects is denoted as npk. Knowing how to find the number of arrangements of n distinct objects, we can easily find formula for combination. The total number of arrangements of n distinct objects is n factorial. Now we have to exclude all arrangements of remaining n minus k objects, which is n minus k factorial, as the order of remained n minus k objects does not matter. So npk is equal to n factorial by n minus k factorial. If we exclude order of chosen objects from permutation formula, we will get the combination formula. So npk by k factorial is equal to nck. circular arrangements. Let's say we have six distinct objects. How many relatively different arrangements do we have if those objects should be placed in a circle? The difference between placement in a row and that in a circle is following. If we shift all objects by one position, we will get different arrangement in a row but the same relative arrangement in a circle. So for the number of circular arrangements of n objects, we have r is equal to n factorial by n is equal to n minus 1 factorial.